Java 9 and food. So Jim Connors is going to talk about Java 9 and modularity. Jim, all yours.
Thank you, Frank. You guys can hear me all right? So this talk is the culmination of, I don't know, a year dialogue with you, Frank, about when are we going to talk about modules? And my answer would be, it's not ready yet. And you would ask me 3 months later, and I would say, it's not ready yet. So we're finally at a point where we think we're actually fleshing out the reference implementation. It's called Project Jigsaw, and it's available for download, so it's time that we go ahead and do that. And the other reason is I can egregiously plagiarize material from the people who actually developed it. So as an Oracle employee, it is my obligation to put this statement up there. And basically, we are talking about future products, so guide yourself accordingly. Okay, so what do we want to talk about today? Java 9 is about a year out, perhaps a little longer. We'll see. And the main thrust of Java is this notion of overcoming some of the shortcomings of the Java platform in the form of modularity. So that's what I want to spend most of the time on. I do have some slides near the end, assuming I get through this quickly, to talk about some other things we think will be in Java 9. But before that, what I want to spend some time on is why do we think modularity is important. So let's get going. So first off, Java is a big, ugly monolith. To put it bluntly, at least in the up until about 3 or 4 years ago. So what do I mean by big and ugly? The current JRE for this desktop is 175 megabytes. The JDK is 335 megabytes. I bet you guys have more than one of these on your system. You probably have a lot more than one. A gigabyte here, a gigabyte there. Pretty soon you're talking about a lot of data. And I bet you have JREs embedded in applications you didn't even know exist. So it takes up a lot of space. So, you know, from a size perspective, we've got to do something about that. From a, big mess, you guys probably seen something like this in the past, right? This is the latest version that I pulled from some engineer, and this is circa Java 6, Java 7 dependency graph. There were other notions of modules then, but these are sort of the main, computational units and dependencies. This is at a much higher level than packages. So if we went down to the package or to the method level, the number of edges on this graph would be infinite. So it's a mess, the bottom line. So we've got to fix this up. And it's taken 7, 8 years to get it to a point where we think we can modularize a platform, and there's a lot of work, to get there. So before we go any further, does anybody know what compact profiles are? Anybody heard that term? Does anybody use compact profiles? Oh, 2 hands, that's more than I thought. So the modularization process has actually been a multi-step process. Java 8 began it. So there are no modules per se in Java, but what we have done is taken that dependency graph, and hopefully this, although rather complicated, is a lot nicer than the previous one. And the ultimate goal was to say, okay, we've broken this down now. Wouldn't it be nice if we could just only use the modules we need when we run Java? That's the goal. And in fact, Java 9 has something called a JLink, which I'll talk about. But we weren't there in Java 8, so what we did do is come out with this thing called compact profiles. And they are well-defined subsets of the runtime, and that's what you see in those concentric circles. So the innermost one with this thing called base, that's kind of the mother of all modules, at 10 megabytes is a very effective runtime. So in Java 8, you can run length expressions, you can do all those type of cool things within that small platform. So our embedded people are thrilled with this. So the question is, can you use it? For the most part, this is available in a private program called JavaSIG Embedded, which is JavaSIG, but for smaller devices, for ARM and PowerPC and things. There's actually a Linux x86 download of this. So you could download this, compare it to how JavaSIG works, and see how they differ in footprint and all that kind of stuff. So anyway, compact profiles are sort of the precursor to modularization for Java. To go along with that, a couple of things. First off, anybody know what JDEPS is? JDEPS is a new utility that's been introduced in Java 8. It is enormously important and will be more so for Java 9. It's a dependency analyzers. So you can run JDEPS over a jar file that somebody gives you, and you get all types of neat information. One of them you notice is JDK internals. So for you folks that run com.nis.unsafe. You'll be able to notice that. But the other thing is, one of the other options available is this minus profile option. So you can run JDEX minus profile over a jar file, and it'll tell you what compact profile it adheres to. So if, for example, it works in compact 1, you can actually get rid of all that runtime and just use compact 1 and run your application. So that kind of stuff. Other thing that we've enhanced, and you'll see with Java 9 too, is JavaSIG. So the compiler now has a profile flag such that if you specify a profile like compact 1, it'll look at your source, and if you're not compliant with the API, it'll tell you. So at the source level, and by the way, the IDEs have been updated to support this too. So if you want to program to a much smaller profile, you can. All right, some other things. Why modularity? This is probably one of the biggest problems with the Java language, the notion of access modifiers. So we all know about public and private and protected. They work extremely well in classes, they work extremely well in packages. However, if you want to share data across packages, but do not want to expose them to the world, you cannot. You have to make those types public, and what happens is you expose a lot of internals. The poster child is sun.nis.unsafe. This is an internal API to the JVM that people use, and now we are in a conundrum. So the problem is, when you want to share a lot of data, you can't unless you make it public, and by doing so, you have people using things they ought not to. And we'll get more into sun.nis.unsafe in the future. Okay, final thing. So if you will, I did get the opportunity, I know Frank was there, to go to Java 1, and Mark Weinhold, the chief architect of Java, actually put up a Wikipedia entry for jar hell. So we made the big time, we're in Wikipedia now. So this is a command line invocation of NetBeans, right, to give you an idea. So the class path is a huge problem in Java. What do I mean by that? First off, for those of you that are developers and have played around with the class path, my guess is your philosophy is as follows. I keep adding crap on the class path until Java stops complaining. That's probably, right? This is God's honest truth. And the end result is you get something like this, and on this class path are multiple classes with the same type of name, packages of different versions with the same name, and the question is, which class do you get when you run? The answer is, it's the first one that appears, even if it's not the one that you want it to be. Heaven help you if the class you really want is different. You're going to get some crazy, unpredictable errors. So clearly, this problem has to be solved. And this is, some of the things that we want to address with the modular system. Okay, so thank you for that introduction. What is Jigsaw all about? I would say, of all the bullet points here, it's really an effort to make large applications easy to maintain and deploy. Right? The end result is, if we do that, we think we'll improve things like security. So for example, if you define boundaries between modules better, that's secure. If you use less of the runtime, that's certainly more secure, right? Less attack vectors. Also, we're going to do a lot of work to make performance better from a startup perspective. Right now, we are basically loading this ugly rt.jar file at 40 megabytes in possibly the most inefficient way possible. So we'll have a new runtime image, and things should get a lot better from a performance perspective too. Okay, let's get into our brief introduction to modularization. This is a combination of 4 sessions at Java 1, so I'm going to probably talk faster than I normally do, and we'll probably go this pretty quickly in order to get done at a reasonable time. So, what's a module? The only takeaway I want you to get from this slide is a module has a name. A module is a self-describing collection of code and data. And again, the name we're going to use is, in this case, the incredibly original com foo bar. And what does a module have in it? A module's got code. In this case, where it's showing that the module has 2 packages, com foo bar alpha, com foo bar beta, with a couple of classes. Now, it is possible and actually likely that a module will also have native code. It'll have binary data configuration files. For the sake of simplicity, we will not get into that now. Okay? So the question is, in Java, how does one describe what a module is? So Java 9 introduces a new file called module-info.java, and the module-info.java file gets put in at the topmost level of your source tree. So what you see here is module-info.java at the top of the tree, and then you see the com/foo/bar/alpha and the classes and that go below it. And the way you describe a modularizable file is as follows on the left-hand side: module, keyword, module name, open curly bracket, close curly bracket. And as we progress, we'll fill in more of the contents of what goes into this module file. Okay, we're taking baby steps here. All right, so the first important thing to think about, the concept to think about in modularization is this notion of dependencies. So the way we introduce dependencies in the modularization system is via this requires, yet another keyword, requires clause that goes within your module info file. So you see here we have a confu bar, think of it as a library, a confu baz library. By introducing this requires clause, you have dependency on it. You read that module is what ends up happening. Take it one step further. Here's a situation where you have two requires clauses, and you see that confu app, now we have another module we introduced, has dependency on this confu bar and java.sql. So the question is, what's JavaSQL? It's a platform module. It's part of the Java runtime. Think of it as the module that contains JDBC, the database access. And we'll get more into platform modules in a second. So as we continue on, what we're going to do is build out this dependency graph. And what we've introduced in this slide is a module all the way at the bottom called java.base. So java.base is the mother of all modules. You don't have to explicitly require java.base, it will automatically be part of your dependency graph. Why? That's where Java lang object exists. So clearly, if you do anything in Java, you're going to do this. So it's there. So again, we're going to flesh out this dependency graph as we go. What we introduced here was this java.base module. This is about 10 or 12 megabytes, depending upon architecture, and you could theoretically have a runtime with just that. So let's flesh out the java.sql dependencies on the right side there. What you see is that Java SQL has dependencies on XML and logging. We'll get into logging in a second. So the question is, why is there this dependency for Java XML? It turns out that JDBC has an XML type, therefore it pulls in the XML module. All right. So let's go back a second here. What I want to take a look at now is this confu app, Java SQL, Java logging scenario here. And we'll begin to look at how one might see code in this sort of dependency. So what you see in the middle, on the bottom part, is this notion of, well, not this notion, in the SQL package, there is a driver class. This is probably one of the most popular classes with JDBC. If you're going to use JDBC, you're probably going to run into this. Okay, and within the class, the driver class, there is a method called logger. There is a method called getParentLogger that returns the logger. All right, stay with me. Up top, in our confu app application, we're going to instantiate driver D. Okay, we have a dependency to SQL. Everything's good. And then we're going to call this getParentLogger thing. Now wait a second, logger is in a module that has a dependency below SQL. How can we do this? Do we have to do something like that? Put a dependency for logger too? If so, that would be really, really bad. That means we'd have to compute the transitive dependencies of your libraries and their libraries, and so on and so forth. Not to mention the fact that if those libraries change, this would be very error prone. So to resolve this, what we did is introduce what we call an implied readability. So now, if you're a good citizen and you create libraries, you should tell the world what you require. And the way you do that is a requires public clause within the module info file. All right? So in this case, what happens is confu app will read Java SQL's module info. There is a requires public in there, so we will furthermore read those modules in order to complete this dependency graph that we're sort of building out as we go. So if we go back to our original dependency graph, the orange links indicate the implied readability. So now we have a complete graph of this particular application. So this is the type of data structure that gets loaded into your runtime system. And with this, we can prove certain degrees of correctness. You know that everything that you need is there. And we call this a reliable configuration. So we talked about dependencies. Another important feature of modules is this notion of encapsulation. So again, we talked about the fact that the JRE is this big monolith, and there are lots of things in there that are public and shouldn't be. So with the module system, now you'll be able to create modules and have a split personality, so to speak. In this case, what we're showing is we have a COM-foo-bar module. On the left-hand side, we have two packages, COM-foo-bar alpha, COM-foo-bar beta, which are exported, and they're exported by virtue of the fact that in the module's info file, there is an export clause. However, on the right-hand side, you see there is a COM-foo-bar internal by virtue of the fact that it's red X to give you an idea that it's not exported. And the reason why, because we did not export that package within the module info file, it is not accessible. Very important point. Even if there are public types within that internal class, an internal package, you cannot get at this system within the module system. All right. Let me say that again. Even if you have public types within a non-exported package, you will not have access to that in the module system. So just to look at it a different way, what happens is COM-foo has a dependency. It quote unquote reads the COM-foo-bar package. The module info file exports a certain number of packages, and it does not export other ones. The ones it does not export, you do not have access to, again, even if they have public types. To take it one step further, if we do not read this module info file, we will not have any access, even if they are public. So there are two conditions to getting access to public types. Number one, you have to read the module info. Number two, it must be exported. If it isn't exported, you cannot read it. All right? So you get the feeling that this is kind of important. For the third time, with Java 9, public does not necessarily mean accessible. So there will be cases, there will be assumptions out there that when you're dealing with code that make the assumption that it's a public class, it's a public method, I have access. Not necessarily the case. All right, so this is one of the disruptive changes for Java 9. We try to do a good job to make this as upgradable as possible. There will be situations where this is going to be a condition for you. So I showed the spaghetti mess way in the beginning. We showed a sort of a simplified version for Java 8. This is what the Java 9 dependency graph looks like, and there are two parts to it. Apologies to the colorblind, for that matter, apologies to the blind. The orange represents the Java SE platform. The blue is the JDK, the superset for the tools. And again, this may look kind of complicated, but it's drastically simplified. This is the culmination of probably 7 or 8 years of work. There are no cycles in this graph. There are clean dependencies. And what you see is we formally now named the modules. So you see Java dot for the Java SE runtime and JDK dot for the JDK runtime. And each one of these are modules now. So for example, java.base has a module.info file. The VM has been organized such that you build that first. And once you build that, you can build the other modules with their module info files. You can say a dependency on this, and it's all been done. That's a lot of work. So not only do we offer modules to the developers, it's part of the system too. The end result is this: when you get Java, if you download the Java 9 Early Access, which is available, there's a whole bunch of new command line options for Java and jar and JavaSIG. One of them is this list mods, and this is the full runtime with the JDK. And there are about 60 modules available. You can see where Java base is there. It's the third one down from the first. There's Java SQL and Java logging that we talked about, but this gives you a feel for how the package is organized. And we're going to talk about the runtime image and how that is different too in a few minutes. All right, so how does one compile this? There's nothing crazy about this yet. Basically, we're just specifying a directory where these things are going to reside. You can see that, again, the module info file is at the topmost part of the tree. And by the way, we do make assumptions about this convention where, if you look here, we have source, module name, in this case source, COM-foo-bar status, and then we get down to the source tree. So module info will be at the topmost level, and then you see the source com through baz, com foo baz, and then you get to where you need to go. So that is the assumption how we organize things, and we'll talk about how you package this up. But if you maintain this tree structure, you can treat this as an unpackaged module, so to speak, when you want to use it. So you guys know about the class path. It's important to talk about this concept within Java 9. There's something called a module path. So if you're familiar with class path, this shouldn't be a big stretch. This would be a sequence of directories where you would look for modules when you're compiling or linking or running applications, right? So thus now we can add a new option to JavaSIG, minus module path, or MP for short. And you just list a directory where those modules are. So we compiled the com.foo.baz directory earlier. We use that in our mods path now, and then we can go ahead and continue going. I think this is pretty straightforward. So with that, to start up an application, we can issue Java with yet another new command, another new command line option, the -m. And I promise this will get a little simpler, but the long way of doing it is you specify a module name and then a main class. So it's module name com.foo.app / com.foo.app main as the main program. So that's how you can execute a Java program that's part of the module system. All right, so what happens? What's happening at runtime here? Well, the first thing is com.foo.app starts up. It opens up its module info file. It notices it has a dependency on com.foo.bar and Java SQL. It also, whether it requires it or not, will open up java.base. Okay, so we're building this dependency graph. We compute the transitive dependency graph, and we finally get to this, as I mentioned before, reliable configuration. And this is a good state, right? We know we have closure for all the things that we need, and we, again, can prove certain amounts of correctness in this configuration. And chances are, if you're going to create a complex application, you're going to need a little help if you have a lot of modules. So what we provide now is a new option called -xdiag::resolver, and it gives you an indication of how these modules are located and resolved. Now, what we're showing you here is a shortened version of the long list of it, but you get a feel for what happens during this process to generate and create this graph. And again, this is going to be useful as you start creating complicated applications, or you're migrating other applications to this platform. All right, so far we talked about encapsulation and dependencies. Now the question is, how do you package this up into other than, what we showed before was exploded directories with class files all over the place. That's not the way you're going to distribute these. What you're going to do is package them in something called a modular jar file. There is another option called a JMod. I'm not going to get into that now, but you may see that mechanism as a means to provide these modules in the Java platform. But think of a modular jar file as not really much more than the jar file that you know and hopefully love. The difference is it has a module-info.class file. So it's a jar file with that sort of additional metadata. Okay? So with that now, let's go ahead and just create this example creates a simple modular jar. So we point it to a directory, the module info file will be there. And what we do is we also include a little additional metadata, and there are many options you could put here. This one just simply specifies what the main class is. So we create a jar file with the main class, with the module.info file, and the end result is what we can do is a new option to jar now. You can print out the module information. So what we get is the jar file, then it opens up its module info file and it reads out its dependencies. There are no exports, so it doesn't show up here. It points out what the main class is. And if you have something more sophisticated, there is more information that can potentially be printed out here too. Again, we're sticking to simple stuff here, so we get a feel for what's going on. So now that we have specified the main class within this file, we can go back to that Java invocation, and it's a lot easier now. You start up Java with the module path argument, right? That's where your modules are. You specify a main module, and because within that there was a main class, a main program started up, it knew to look into the jar file to find that. right? So this is a lot easier, hopefully, than the previous indication. Okay. All right, so very important topic now. So you've got a bunch of applications out here. You depend upon class files and jar files and stuff from all over the place. What happens if it's not modularized and you want to put it into your application? We fully understand that you're not going to be able to, from one point to another, get from non-modular to modular. So the niceness of this system is that this modular jar file can act both as a module and a standard jar file. So recall that the name of the important file is module-info. The module-info is not a valid Java identifier. It's got dash in it. So the older versions of Java will not recognize it. They'll just ignore it. So you just have a plain old jar file. So the idea is now you can just simply either put this jar file on a class path, or you can put it on a module path. So the question is, there is one qualifying thing here. If you compile for Java 9, clearly the Java 8 system is not going to understand it. So what you would need to do is compile with a target 8 or release 8, and then you'll be able to use it either in the Java 9 framework or the Java 8 framework. So last example, we showed how you can put this app.jar on the class path. Same exact command works just fine with the module path. And perhaps most importantly, you can mix the class path and the module path together. So why is this important? Let's say you've got an application with 100 jar files. You saw the class path that I showed. I'm sure you have the same thing. Let's say only half of them are modularized. Well, put them on the class path. Put them on the module path, put the other ones on the class path that you work on. So as you slowly but surely migrate over, this is the mechanism by which we'll let you do that. Another important concept. This is, to me, pretty exciting. For the first time in Java's history, you actually have this notion of a linker. So we will now enable you to provide custom images with subsets of the runtime if you think that's important. Clearly, embedded people love this, but also people that are hosting hundreds of VMs on a system, this is attractive. You can save a lot of space and many other reasons too. A couple things to point out here. On the right-hand side of the diagram, the runtime image for Java 9 is drastically different than what you're accustomed to. So you may recall if you have a JDK, there were two bin directories, right? There was a JRE directory, that's all gone. There's one bin directory, there's one conf directory, that's where all the user configuration stuff will go, and everything else you shouldn't care about. All right, so there is no rt.jar, there is no tools.jar, there's no JRE directory, and we deliberately not expose the implementation details of that because it will change. But it is far more efficient than the original 40 megabyte, 50 megabyte rt.jar file that you had to read serially in order to start up. So there is a tremendous opportunity to have startup be much better. They're already talking about ahead of time compilation options and all these other things that you can do to make this image far better than what you're accustomed to. So the downside is there are applications that will open up rt.jar and tools.jar like IDEs. So how do they do that? Well, a new interface is available called the JRT provider. So they'll open up this JRT provider and it'll enable them to cycle through the classes to load them as they need them. So, example implementation of the JLink command. So we issue this JLink command, and this is the simplest of commands. We're just creating an image with nothing more than Java.base. I pointed out that this is something like 10 or 12 megabytes. And you can see that what happens is it outputs a my image and a my image directory. There is a Java command within there. You do a list mods on it, you get one module. 10 to 12 megabytes. And again, this thing can run lambda expressions and all those kind of neat things that you guys like. If you limit your API, this may be all that you need, which is pretty neat. The other thing you can do is bundle up your application along with whatever you need by computing this just transient dependency graph and get a custom runtime. So if you don't do things like dynamic loading, reflection, all that kind of stuff, you may have a limited environment and you get rid of all the stuff you don't need as a runtime environment. So our sample that we've been sort of running through, here's an example of how you create a JLink image with only the 7 modules that are required. Okay, this is what? Maybe it's 10, 15 megabytes, 20 megabytes versus the 300 megabytes, or whatever you used to use. So I was having a discussion earlier. This is interesting to me. If you want, where Java might be might be back in play for things like iPhones and Android, where in the past Apple would not let you put a JRE on a machine, but they will allow you to include the runtime with your application. You couldn't do that if you had 175 megabyte runtime, but if you have a 10 megabyte runtime or a 20 megabyte runtime, I don't know about you, but when I download an app, they're usually 20 megabytes easily, right? So this could be very interesting, I think, in the future for those type of platforms. Okay, so I got about 5 slides. Are we okay? So we talked about modules. What I want to spend a few minutes on now is what else we think is going to be in Java 9. Oh, before we do that, a couple things. You can get Jigsaw now. You can download it. Good stuff. Play around it. I would recommend. Actually, I wouldn't recommend, because then you'll know I just copied whatever these guys said. There are 4 YouTube videos that highlight from the guys who created this, Mark Reinhold and Alan Bateman. These are the people that actually, are the chief architects here that do a great job. They're about 45 to 50 minutes each, and you'll definitely be better educated, including Q&A about what this is all about. So, a couple things. So, I have personally attended several sessions where they espouse on the benefits of com.list.unsafe, this wonderful, mysterious internal package that's part of Java. The problem is, this is a tremendous headache for the people who manage the JVM. And there are lots of these internal APIs. The goal is to ultimately get rid of all of them. Not immediately, including this.unsafe, because there'd be a tremendous outcry here. But we do have a plan to openly encapsulate all of these APIs and provide alternatives if we need to, right? So we understand that doing this is going to be painful, so we have a compromise, and let me read this verbatim rather than explain it. First off, if an API has a supported replacement in 8, it will be encapsulated. So if you want to use it in 9, you're going to have to go to the alternative. Basically, if we provide an alternative, it should be equivalent or close to it. So that should be painful. Number 2, if it doesn't have a supported replacement in 8, it will still be available in 9. So you have a reprieve, all right? Point 3, if it has a supported replacement, then it will be deprecated in 9 and ultimately removed in 10. So again, you have a reprieve too, but we're trying to get you to the point where if we're trying to make replacements, if they're there, please use them. And of course, knowing that nobody will listen, we do have a quote-unquote get-out-of-jail-free card. So there is an xadds export where you do is you specify the packages that you want really to use, even if they're internal, and it'll still work. So that's our compromise. But please, we ask that you behave, but nobody's going to listen. All right. Now I have like 3 or 4 slides. So reports of the demise of Java are greatly exaggerated. At any point in time, there are a lot of these sort of surveys that determine what's the most popular language. Either C or Java are usually 1 and 2, and it depends upon immediately. Usually what happens with Java is as a new release comes out, it gets sort of a little better. So that's all good. However, if you look at the right side, what we have noticed is the trend that Java is no longer the most popular computer science 101 language. Certainly any computer science program worth their salt will let you use Java, teach you Java, but not initially. And we'd like to change that. And the problem with a lot of what they've been telling us is it has to do with the fact that the barrier to entry to Java starting out is tough. You have a computer science 101 student, they got to write a Hello World program, they instantiate a class, public static void main, left early, all that kind of nonsense, in order just to print Hello World. So it's just too hard. So Java 9 will introduce this thing called a JShell, and you can download this now. So instead of doing all of that, you just type, you start up the JShell, you type system out, println, hello world, don't even need a semicolon, and it'll fill in the lines for you. So it's a much nicer way to experiment with snippets of code rather than creating this whole big example of stuff. So hopefully we'll get a little bit more people interested in using Java again, at least elementary. So okay, last slide. So what else is going to be available? So these are a couple of things that I picked out quickly. Process API update. What do I mean by that? So you'll have a little bit more knowledge about processes, be it Windows or Linux, so you can get a PIDs process trees, that kind of stuff. So a little bit more information that might be useful for programmers that need that stuff. Lightweight JSON API. So right now, JSON, although there are APIs for JSON, it's not part of the platform. So it's high time to include it in. So this will be ultimately part of Java base, I think. So it should be part of the base platform in order to use XML, JSON. Somebody mentioned earlier about the date and time APIs, so I guess this is an appropriate analogy. Money and currency APIs will be a big thing. And in fact, the spec lead is from Credit Suisse with help from JP Morgan Chase and Goldman Sachs. I wonder if anybody's here that does that. So this is being done here, for the most part. Improving locking, this is a performance thing. Segmented code cache, what we mean by that is just as the garbage collection VM is segmented, right, based upon long-lived and short-lived, we're going to do the same thing for compiled code by the JIT compiler. There will be stuff that's permanent, other stuff will be short-lived and maybe not as optimized, and we think we'll get a peak performance going on it. And from a logging perspective, we want to have a centralized logging infrastructure for the VM that helps with messaging, and hopefully we'll help you guys too. So again, I don't know how much time we have. A couple of questions. And by the way, experience has told us that generally the modular system generates a ton of questions, which we may not be able to answer. Questions? Yes.
I heard a rumor today about a delay.
You did, didn't you?
Speak to this?
Yeah, I can speak to it a little bit. So Mark Reinhold, the chief architect, did send out an email today. For those of you that are interested in monitoring Java 9 progress, you can. And he proposed delaying, he didn't mention the release, but he proposed delaying the feature complete stage from what we thought would be late 2016 to March 2017. It hasn't been approved, people are yelling and screaming, but that's all. He's making a proposition now, the community is going to chime in and we'll see what happens. There are other entities involved, like Oracle, maybe they're not too happy about that either, but, so, possibly. So that gives you more of a reprieve, if you're not using the module, right? Yes?
So usually in class path, the first class to be used is more...
the first class is the, first one you find when you get,
So now how does it work between the modal path and the class path if I need something with it?
Yeah, all right, a couple of things. One thing I didn't state in the module path is as follows. If in your module path you have two modules with the same name in different versions, you're done. The Java will not start up. So it will avoid that problem. If you combine module and class path together, you're basically stuck with what happens in the class path world. So again, this is a transition. Ultimately, you want to get off of that, but we understand you need that right now. Question over here?
So what's the point of the module in Java? Will you ever looking for the modular?
So there has been some discussion on the waves about why does it have to be Java? Why can't it just be an XML, right? So this is an implementation and it isn't cast in stone, so it's possible that things will change. I've never seen that, but for some reason the language people want it to be part of the language, and wildcarding it would not really be Java-like, would it? So maybe. Yes, sir.
So is it not possible, so if I have two different libraries I want to use, they both have a dependency on the same module but different versions, I can't do that?
Yes, that's correct. But by the way, one thing, I'm talking about versions. Versions are not part of this system, all right? It's a string. If you notice when they did that list mods, it was like at 9.0. That's kind of a string that we add on later on so that you know the difference. And there's been a lot of questions about this. We came to the conclusions that versioning is really, really hard. And other people have done it already. So Gradle, Maven, Ivy, they've all done this stuff. So we're saying that you probably should rely on those systems to handle the problems that you have rather than us trying to do that for you. But yeah.
Okay, imagine module A depends on java.sql. Java.sql depends on java.logging. Let's suppose module A also wants to directly use a logger itself. Does it need to declare an explicit dependency on java.logging too? Or will it transitively inherit it from java.sql?
It will, because you read Java.SQL. Java.SQL requires public for logging, so you would need to in that case. And by the way, the JDEPS command that I talked about, you can run, as you're transitioning from your standard program over to modules, you run JDEPS and it'll tell you all these sort of things that you need. So you can, in fact, there's an option which says create a module info file for me. So it'll create all those dependencies for you. There may be more than you need. You might want to pull some out, but that's an option. Okay. Thank you.